Right, so we have IAL Pure Maths 2 proof question, okay? And this is, I mean, not tricky, not that tricky, but like at first you don't know what to do, okay? This is a proof question, yeah? Whenever they give this type of question, you have to do some of algebraic manipulation. And whenever you have probably learned proof, that you probably know that there is some cases that we like prove that this is a factor or something like that, yeah, and we say hence a multiple of 2. And then there's another case of proof that you should know that we write it as square. All right, you have learned this in proof in exhaustion. Well, you have to write it in the square form. All right, okay. So here we need to do some bit of algebraic manipulation here. All right, basically that what I call is jottings. Okay, so x plus y over 2. So prove that for all values, positive values of x and y, x plus y divided by 2 is greater than equal to root xy. Alright, and prove that by counterexample that this inequality does not hold when x and y are both negative. Alright, so x and y is greater than equal to xy. First we can get rid of the square root here. Now this is going to be x plus y squared, okay, and this one is going to be 2 squared xy, okay, so square root and the square cancels out, yeah. 2 squared is 4 and x plus y squared, okay, if you expand the bracket you should get x squared plus 2xy plus y squared. All right, and what we can do is we can times this by 4 sides to get rid of the fraction. All right, so we have 4xy and we have x squared plus 2xy plus y squared. All right, now what we can do is we can minus 4xy on both sides, okay, and in order to simplify we can take things on the left hand side. So this is going to give us 2 minus 4 is going to give us minus 2xy plus y squared, okay. Here we need to do algebraic factorization. So what we can do over here is you can just split it up, okay. So minus xy, which is going to give us minus 2xy, but I'm going to split up, okay, to do algebraic factorization, okay. All right, so we can factorize these two terms and these two terms. So we can take a common factor of x minus, okay, y. All right, and same over here we can take factor of minus y x, okay, minus y, okay, squared, okay, not squared, sorry. And we can write this and this into one bracket and this in one bracket, okay, these two, okay, and this is going to give us x minus y squared is greater than 0. Now we need to write the conclusion steps. Well, any positive x and y value is going to give us when squared, okay, when it is squared, okay, because, okay, all right, squared is greater than or equal to 0. Why? Because anything you square it is going to be a positive, okay. Equal to 0, okay. Hence, okay, here you what we can do is we can reverse the process over here. Not necessarily we need to write this, okay. So what we can do, we can write x plus y is greater than 2 root xy, okay. Make sure you reverse back when you write into conclusion steps, okay. So hence x plus y is greater than equal to 2xy, root of 2xy, right? Okay, greater than or equal to, right? Hence equal to, right? So okay, therefore, okay, so here we mentioned therefore x plus y is greater than or equal to 2 root xy, hence proved. And you add a little square there to indicate that you have done end of proof. All right, this is how you do proper proof, okay. Proof by counterexample that this inequality does not hold x when x and y are negative. All right, so x plus y over 2 is greater than or equal to root xy. You need one counterexample to disprove this. So let's assume that x is minus 2 and x is, let's say, minus 3, okay. Minus 2, okay, minus 3 over 2, and this is minus 3 times by minus 2, okay. And minus 3 minus 2 is going to be 3 4 5, minus 5 over 2 is greater than minus 3 times 2 is 6. So clearly 5 minus 5 over 2 cannot be greater than root 6, okay. Hence, okay, hence proved, right? Proved or by a counter example, okay. All right, so this was this question, okay. Your target should be the square. Make sure you can write in squared form. That should be your target, all right. And yeah, try to do some algebraic manipulation that will lead to this, all right. All right, so peace out.